Should we get going, I guess? Well, thank you very much for coming. My name is Rod Soto, and as you may know, I'm part organizer of this conference. I'm here with Joseph Zadeh, and we both work at Splunk UBA, User Behavior Analytics. And today we're going to talk to you about dynamic population discovery for lateral movement detection. And the way we're going to do this is obviously using machine learning techniques. So most of what you're going to see today is basically ongoing research that we've done. And you see a little bit of a proof of concept, and obviously there's stories behind all this technology. So let's get started. Did I just click? Okay. All right. So I'm here with Joseph Zadeh. He's a senior data scientist with Splunk User Behavior Analytics. My name is Rod Soto. I'm a senior security researcher with Splunk User Behavior Analytics. We both formerly worked at a company called Caspita, which is a machine learning threat detection software, and we were recently acquired by Splunk, which most of you know is an amazing product. It's a leader in SIEM, and I had to give it to them. They are visionaries in many instances. They decided to take a risk, basically, acquiring us because they thought the technology was disruptive, and from the long-term perspective, it was promising. So let's get started. What is lateral movement? Lateral movement is a series of actions that are conducted after successful exploitation, attack, or infiltration in an organization's network that seeks to further reconnaissance and expand the reach of attacker by either gaining knowledge of internal network assets or actually accessing them. And what we're talking here is, as far as lateral movement, is what happens after a compromise on a workstation. It can be also an edge device. It can start from an edge device, like we see here. You see there's in this example, we have a web shell, and then from the DMZ, we go to the LAN, and then subsequently we go into the workstations. There are many techniques, which we'll name a few here, that attackers use in order to gain this type of access. And that's what we are going to be looking at as lateral movement. Here's another example where we have, for example, an internet-facing server that gets compromised either by a RCE, remote code execution, or a web shell. And then from there, you can either escalate privileges, you can either sniff information, you can do things like password dump, you can netcat, you can use Mimikat. It depends. So there are multiple post-exploitation techniques that attackers will use in order to gather further insight and successfully access other hosts inside your network. And then eventually, we will move around, basically look at file servers or mail servers or workstations or even domain controllers. It depends on how many layers of protection or isolation, or even if there is something, sometimes we call this defense in depth, depending on how hardened organizations are. But for the most part, we all know this is not the case. So this constantly happens. The main objectives, obviously, of this lateral move is to gain further knowledge of internal network assets and expand access into other systems. Of course, like I said before, and like you saw in that graph, the ultimate goal is to get the crown jewels, right? For the most part, crown jewels, at least for me, sometimes when I do penetration testing engagements, is to get the domain admin credentials. Once I have domain admin credentials, once I have a GP, what you call like a system administrator, you GP result, and you resultant set of policies, RSOP, as a domain administrator, then you pretty much, it's game over. You already have all control from the network. You can add users, you can change passwords. In other cases, like we had seen in some publicly known compromises, can be PII, for example. personal identifiable information where either customers, either healthcare records, and so on. So some of the tools that we have seen as well that are usually used to attain and to pursue lateral move. Obviously, we have keyloaders. We have ARP spoofing, which tends to be noisy. However, it still can be done. We have things such as password dump. If you're familiar with Metasploit, then you know about Mimikatz. Mimikatz is awesome. It pretty much allows you to, provided that you have enough privileges to pretty much crack the hashes and the password immediately, and then pursue things like pass the hash or pass the ticket. Then we had things such as PSExec. We had WMI PowerShell. PowerShell is becoming very popular as a post-exploitation tool. And then, of course, like I just said, the use of Metasploit. We have other things such as, obviously, RDP, SSH, and BNC. And it may sound maybe not feasible that you will use BNC. You will be surprised in how many times in the field we've been able to identify the use of BNC. Attackers sometimes don't even care. And for the most part, it's because they're not detected. And the longer they are not detected, the more, I guess, liberty they take into moving around. So, obviously, the use of exploits, multi-stage exploitation, post-exploitation tools, and things such as, like I said before, pass the hash, pass the ticket, and even brute force tools. Because if you're an organization where your password policies are weak, and you allow your users to have a 1, 2, 3, 4 password, then obviously you are just asking for it. So why is movement detection important? Lateral movement detection important? Well, let's talk about a little bit what we call the concept of dwell or the detection deficit. You guys probably read the recent report from Verizon where they have a nice graph about the detection deficit. The detection deficit is the number of days that it takes to discover a breach from compromise from day one. The longer this dwell, or the higher this detection deficit, obviously, the most likely there will be exfiltration. There will be obviously entrenchment first. Attackers will entrench, meaning they will find a way to create persistence. They will find a way to come back. They will find a way to stay in the environment, and then subsequently, by the use of multi-stage exploitation or post-exploitation tools like the ones that I just showed you, they will be able to move around. And as they move around, they'll find stuff. And as they find stuff, they eventually will hit something that is very valuable. In order for this to happen, obviously, the more time they are not discovered, the longer this dwell time is, the better for them. And that's why it's important to discover lateral move. Sometimes, depending on the environments that we are, and I can tell you this from firsthand. I used to work in an enterprise where we were basically exposed to many of the 0 days that were very popular in the last 2 years on the internet, things like shell shock or heartbleed. And I can tell you personally that is a challenge, even for very large enterprises. Even when you're getting notices with a week or 2 weeks to patch hundreds of thousands of servers, right? Sometimes it's not even possible. And I can tell you that one of those exploits, we were seeing exploits like 45 minutes after it went on Twitter, like after it went on the internet and after it was published. I don't remember if it was shell shock or heartbleed, which one of those. I think it was shell shock. Like in less than an hour, we were already seeing attempts of attacks in the infrastructure. Right, so this is, sometimes we have to deal with this type of situations where, to be honest, it may not be possible to prevent an actual compromise because we're exposed, right? So the rapid detection of lateral movement can reduce and contain, obviously, prevent further impact of a breach. And as you may also know, most of the times, what's the way that victims find out they've been compromised? Of course, it's called pacement, right? Yeah, it's called pacement, right? You find out a pacement. It's like instead of going to MITE or CDCB, you go to pacement, and you find your own PII in it, right? So it is important to obviously pursue the detection. The earlier we can detect, then we can contain and reduce the damage, right? Detection, obviously, on the lateral move enables the SOC, right? Security Operations Center, or Security Operations Department, as well as incident response, disaster recovery teams, to act in a more efficient manner, right? One of the things that we've been seeing lately, for example, is a host gets compromised by a payload, can be Dridex or it can be SUS, and then comes the ransomware payload, right? So the ransomware payload is being served afterwards. The workstation or the host that has been obviously attacked gets compromised. And as you all know, the ransomware problem right now is horrible. Lots of Bitcoins, right, going back and forth. So obviously it's very important to know. Obviously, as we harden and get more efficient in detecting this type of movement, lateral movement, it will increase the cost and it will deter the attackers. Sometimes it's about a cost and deterrence. If the attackers perceive that the time and the skill and the resources that they need in order to compromise your organization is something that is challenging for them or is too costly for them, most likely they will walk away. They will go and find someone else. So, obviously, not only the attackers or the external, but the insiders as well. This type of mechanisms will allow you also to detect insiders, malicious insiders, people that might be in your organization that are not happy, people that are about to quit, people that may be sending emails, people that may be accessing shares, servers, documents that they never actually had touched before. That right there is a red flag. All right, so let's talk about assets, right? When we talk about assets, there's a definition there from Wikipedia. It's pretty much any data, device, or other component in the environment that supports information-related activities. But basically, what we know is network servers, for example, routers, switches, databases, application servers, workstations, printers, and IoTs, right? So I was actually talking about this recently, where there's been cases where you're in these enterprises that are very hard and fortified, and then the IoTs or the devices in the actual meeting rooms are actually vulnerable. So by you being able to compromise the meeting room device that nobody looks at, but it's network enabled, they can move around. They can sniff traffic. They can probably gather passwords. And it's definitely an open door. So we also need to pay attention to that. And when Joe comes in and starts talking about the framework that we're working on, you would understand how we can approach this problem. So why is important the asset management? If there is no asset management, there's no risk analysis. There's no possibility for us to establish any risk if we don't know, if we're not aware of what our assets are, right? Another example, one time I did an engagement where we were able to successfully access the organization because we compromised a server that was used by a third-party partner. So basically, this third party, this partner or this organization was able to, or was allowed to use a subdomain from the organization that we were pen testing. But because there was no communication, with the actual client or the organization that we were working with, they had no idea that server was out there. And neither the partner forgot about it, left it open, we broke into it, and then we were able to pivot inside the client. So that is part of asset management. You need to know not only yours, but what are you exposed to. Unmonitored and unsupervised access are likely to be targeted and exploited by attackers, which is exactly what I just said in the example I just brought up. Lack of OS, application version patch level, and updates increases the risk of compromise. You don't know what you need to upgrade. You don't know what you need to fix if you don't know what you have, right? There are companies that, for example, have legacy applications. They may have still Windows XP. By the way, the rate of Windows XP is still high nowadays in 2016, right? There are also people that bring their own printers, their own devices, their own access points to companies. That is something very dangerous. So that is why it's important to know what is it that is in your network. You had to inventory, you had to manage it. You also allows you to enable access management to resources inside the perimeter, because most likely what we're going to be focusing here inside the perimeter. And again, enables your security people, security operations, incident response, disaster recovery to identify and assess resources in case of an incident. So let's talk a little bit about practical machine learning for security. So here we go.
Hi, I'm Joe. I'm just Rod's partner in crime. I work on a data science team. Now it's called like Splunk Security Behavior Analytics or User Behavior Analytics, and so I think one of the unfortunate things about kind of this like a lot of the buzzwords in industry like machine learning and sort of how we blend these techniques into actually like creating practical value for defense or offense is, I mean, we're seeing a lot of like kind of mismarketing of these terms. So kind of hopefully like this talk, I mean, it wasn't really clear in the title, but hopefully this will sort of give you kind of an under the hood illustration of like how we use open source tools and kind of blend them. I mean, it's basically a bunch of pictures instead of showing you the actual code. But like, so just like stepping back, like, we always want to use the right tools for the job when we have a security problem. And part of the problem when we talk about like machine learning in this space is machine learning is really good for pattern recognition. And so if you're dealing with like changing TTPs, if you're dealing with a model of an adversary who's adapting to your defenses, like you sort of have to ask the question: what does it mean to write an algorithm that detects patterns that change over time? So this isn't really necessarily like the right use case for pattern recognition tools without kind of like realizing maybe how to kind of separate the model to adversary and break it down. So I mean, this is just more like kind of practical generic advice in where we see sort of like the application and the right tools. Like when I get to a sophisticated shop and we're sort of engaging with like a mature security operation, they have this model of, man, maybe this is kind of small for you to see, but I mean, basically, like on this side is sort of the kind of model the adversary, like in terms of complexity or just like resources, right? Like a nation states can have so much resources, really, like to even try to automate the problem of. I mean, this is like automating spies here. You really have to have a human component and an intelligence operation to sort of deal with the more high level complexity. And so on the x-axis here, it's just sort of like. Man, I guess you can't really see this in the resolution, but these are just sort of like different point solutions. So like if you're an enterprise, you say you have IDS and antivirus and stuff, maybe just a couple of different sort of technologies, like this sort of will give you kind of a way to gauge maybe how good you're able at catching certain kinds of adversaries. So we kind of use this just as a way to kind of scope and then overlay that with the fact that kind of in my experience, a lot of times. This is the space I want to automate, like with tools like machine learning and stuff like that. So that's just sort of, it's kind of like a little fact we try to use in conversations. And then, okay, so here's kind of like the next, this is just more sort of generic. mainly to illustrate to you, like when we build we build a software stack that's leveraging these tools. Some of them are machine learning libraries, and there's a brittleness to this process. This is why it's not always the right tool for the job. So so what happens when you learn something? This happens in our brain. There's sort of an analogy between what it really means to learn something and what it means to compress something. And when you kind of look at, well, why is that? And the resolution here is kind of ugly, but basically what I just did here is an example of like showing you like a learning process. I took a R code. I mean, it's just sort of like out of the box, like some data set in R. I think like 1,000 rows, and then we fit a linear model to this data set. We're making some predictions saying this data set's about cars, so we're saying the miles per gallon is sort of a linear function of weight, cylinders size, and a couple other things. I mean, and basically when you train an algorithm, the output is you take this whole data set and you kind of get. I mean, there's metadata here too, but basically you get like a point, and this is the coefficient of the slope. So we've kind of thrown away all this information, and we sort of have a hash of a signal. And this happens in our brain too. That's why we don't like when we don't have to learn something as a lion every time. Otherwise, we like certain like survival instincts. You want to rely on the hash and not like having to learn something. So so actually, like just to maybe illustrate kind of like where we use this like in practice is actually this is a. Can't see this either, but this is like a set of domain names, and we had like incident responders label them good or bad, and we built a behavioral profile of the domain, and then we've trained. This is MLlib. I program a lot in Spark, and we trained a random forest on this data set essentially, and the challenge is when we build a product. So we build a stack to sort of automate this problem of learning and relearning. And when it comes to like dealing with an adversary, it turns out we have to build an API that's like pretty complex. So most machine learning applications, you don't even like, you don't really have to worry about this problem. But this is what's called we have to define as programmers what it means for a model to forget programmatically, what it means to remember, what it means to relearn. So basically, we have a bunch of models that evolve in time, and we satisfy an API where we can basically compare them to each other and kind of know which one's the best. So that's just sort of I don't know, practical, just machine learning kind of, like I see it misappropriated a lot in the industry. So we try to be practical about it and understand it is a brittle process, so it's just one little tool for a much broader use case. And now we're going to kind of dive into the model itself, and starting a security quote with a Sun Tzu. Any security talk that starts with a Sun Tzu quote is probably not good. But all too often we forget the first rule of battlefield. The battlefield, the attacker can escape everything and cannot escape the terrain. Choose the terrain, use the terrain, and we win. So I grew up in a NOC. Like I was programming like HPUX like in the 90s. I was on a help desk, and I did a lot of layer 2, layer 3 racking and stacking, building like network management tools and stuff. I used to use MRTG a lot, and this was before like the big data revolution. So kind of what I learned a lot about. One thing is like the difference between routing and switching. Like because we lose visibility into the LAN in a large enterprise, like a lot of the lateral movement is really hard for us. I mean, without PCAPs of local area network traffic. There's sort of a loss of signal to really be able to like 100% accurately detect some of the things Rod was talking about, especially if you have a lateral move on like a switch, like between two switches, and there's no, like the hosts are not even like, being routed anywhere for you to see kind of the sort of higher level traffic. And so kind of what we're going to describe here is just basically like what we built in code, and it's just like a model that is kind of targeting a couple of use cases, and so I'll get back to them. But basically, we're just kind of walk you through sort of the methodology here, and it's kind of just it's sort of easier. Like I try to put everything in pictures, so it's sort of easier to think like what we're doing just in terms of the flow. This isn't like UML or anything. But I tried to like just break down each one of the kind of components and just sort of illustrate kind of the open source nature of what we're doing. I mean, I used to do this for like as a consultant for like shops that are 50,000 users in size, or maybe probably the biggest one I did was like around 400,000 users. It was a really big data problem, like to sort of overlay a lot of these different flows. But if you're on the defensive side of things, I think this is sort of natural kind of maturation of what we saw the first gen SEMs doing, kind of what we're going to describe here. And if you're on like the offense side of things, I would expect more and more like sophisticated shops to be starting to use techniques like this, either in a product stack they buy like something like we built, or just, I mean, I just used to do this like with MPPD SQL databases basically. So so instead of showing you code, I used Gephi. This is actual data. This is sort of the result of the model. Basically, what happens is there's a few steps. The first step is just take a bunch of data. There's no structure here, and then we perform an identity resolution, some fingerprinting processes. That's sort of all kind of described as basically color coding the graph, and then we have logic. It's essentially sort of very very intuitive ways to describe what happens when like a relationship in the graph is going to change over time. And we're really kind of targeting some of these use cases. Like there's like a video a couple years ago by the CrowdStrike guys called Beyond the Indicator. It's pretty interesting stuff. I mean, it's talking about a lot of these next gen tactics we're seeing, where the malware operators, because the malware is in memory now, there's not going to be any beaconing once they're done. Like they push everything from the web shell, do their thing, and then like the tricks I used to use like 4 or 5 years ago to just build models to detect malware beaconing, like that tactic is slowly changing. And so this is one of the way, like basically sort of the web shell problem, that the way CrowdStrike describes it is sort of like one of the main use cases we're targeting here. So like just walking you kind of through the logic and what we do. Step one is basically we take a bunch of data for an enterprise. You can do this PCAP data, which is sort of the worst case scenario at scale. Typically flows, and my favorites are Palo Altos. So kind of show you some examples from Palo Alto data. And this is sort of like, I've had to do this in so many different cases. We built this as like a workflow in our stack, but I think any SEM I worked on, like that was like the great thing about using like the first gen SEMs, is they kind of give you this normalization and this roll up for free. But we'll walk you through sort of like just kind of like what this means, identity resolution. There's one really cool thing I would point out, if you guys haven't seen this, kind of like this is a pretty, you have to be a pretty advanced shop to really be able to implement this, but there's this Unix paper that the Google guys, there's 2 papers that Google guys has put out, and it's based on this idea of inventory-based trust. It's pretty cool, like check it out. But there's just different ways we can interface with an inventory system. If we don't have one, like worst case scenario, this is sort of what we have to do ourselves, is kind of build some flow. So just the process of identity resolution itself is like, I mean, this is sort of the logic we have to implement, and it becomes really complex. Like we built a streaming solution, so we have like live real-time ingest coming along with our Spark jobs, and it becomes like a really interesting computer like sort of an algorithmic question, like what do you process first, and when you're processing in real time, how do you resolve an identity? So like, let's just kind of walk you through. Yeah, I mean, there's a lot of sort of cases. You can be in like a fully offline mode or an online mode, but the key idea here is that there's like a notion of state, and the state changes over time. I mean, in identity resolution, we're usually just tracking a couple different parameters, because the issue is when we want to build a history for a particular IP address, a lot of times in the LAN, when there's DHCP churn, we lose signal on the history of the behavior. So basically the goal with identity resolution is just to give you like as many key indicators that like a primary key that you can kind of use that is more stable than IP address. Like, and you can get pretty fancy with this. Like I was working with the EMC guys who were right after the RSA hack, and they were just building this whole identity resolution framework because the RSA hack happened over like a compromised VPN account, and so what they wanted to start doing is they even built like, they went one step farther and have some more tables that are probabilistic. So they're sort of fuzzy matching in the sense that they're using people's user agent strings. They're giving a confidence of what it means for a VPN user to be logged in, that's actually that person. And so, but yeah, so basically this is the first step we will implement in kind of, in either like a custom workflow for a particular enterprise, or it just has like a SEM. This is sort of like the key ingredient to really get working right. So once we have the identity resolution in place, then we can start like leveraging kind of different levels of signal. And that's how we can kind of break this down in a couple steps. But what we do is just, like the goal is kind of in one sense, and there's a lot of like simple like just rules you can use here, is to discover DMZ blocks, like DMZ assets, right? And basically routable IP addresses that are actually part of your own public IP space. And if you're taking proxy logs, pretty much firewall logs or netflow logs are sort of the data we used here. I think this actual visualization is like Palo Alto and maybe Blue Coat. But we're basically just taking a couple of different signals, and proxy data is really good for this problem of the human fingerprint. When we want to say, okay, there's a human behind this IP address. So basically, this step, all we do is we infer key properties of the topology. And there's just like, so these features are, I mean, so maybe I'll just kind of show you the output of some of the code. I mean, it's really simple stuff. Like if you've kind of studied graphs, like what we're kind of describing here is like the in degree or out degree of a node in a graph. Basically, how many edges are pointing to a node, how many edges are, and these edges are directed. And so I had to take some of these slides from like a PhD statistician's intern project. So like there's a bunch of math here, but don't even like worry about it. More kind of what I want to show you is just basically what we're building in these steps is a bunch of tables like these that are per entity in the environment. And this gives you like, you'll see IP addresses like after you just do this simple step, it's like you'll see IPs that never talk to any routable IP address, so they have this only LAN presence. You'll see IP addresses with flows both from the DMZ and the LAN, and you can just start kind of getting a sense of like their importance. And the reason we need to do that is to start to
The person wants a question.
Oh, yeah.
I like where you're going with this, and one of the questions that I had immediately when you started talking about kind of connecting these as sort of vertices and flows inside a graph, are you using a graphical database storage store? Like, what kind of storage are you using? Because those could give you the same sort of techniques to.
Yeah, so we do have Spark under the hood. So we're actually using their library called GraphX, which I think just basically gives us like a free representation. And we get like once you get those libraries, you can do kind of sophisticated stuff. So we'll compute the page rank here. We'll basically throw a bunch of algorithms at it, but not all of them are like. It's more sort of mapping them to key properties and like how many I kind of want to answer these questions, like how many hosts talk to this IP, and sort of just mapping that down to like it's like a little table, So we basically the output is a bunch of these things, and because this is a big data problem, so we're doing this sort of in parallel, like in sort of like a MapReduce type job. So that's basically step 2 is just discovering the topology, and then step 3 is actually kind of giving this this topology like color, and what that means is well the goal is really like if we had an inventory asset management system, ideally this stuff would be up to date. But when you start dealing with like large shops, like I was working in a healthcare environment, they have the shadow IT problem, and a big issue is like once you get to a certain size in healthcare, like people will plug in biomedical devices and all these IoT things, and you just like it's even when we had a really robust like inventory tracking service, we just get all these things that wasn't being logged in inventory. And so that's kind of like where I would start to play this game is like, write some SQL or write some code to sort of help just like kind of use your own data to add to add a little bit more signal here, and that's sort of like the power of kind of data-driven solutions in general is like you can't really get this telemetry without your own data. So what are we? And this is sort of thing where things can kind of get complicated, and in my experience, this really wasn't the right, like, we didn't use machine learning to discover these profiles. We just used like intuition and kind of studying like known servers in different environments, and we basically kind of build up a whole. I mean, in machine learning terms, we call it a feature vector, but it's basically like a bunch of tables. Like for each entity, you kind of get a bunch of like little like facts about like the graph properties and all these things, and over time, we can track those in day 1, day 2, day 3, and what we're tracking here in these sort of silly pictures I'm showing you is just a bunch of statistics. Some of the graphs are not so ugly. But basically, like these, I can't read anything here, but we're just like for each profile, like kind of the power of the big data approach is that I can sort of like just compare an individual profile to himself over time, or like, and we do this pretty much for everything. Is also sort of asking the behavior of a particular subnet or a particular kind of group. Compare the behavior of the individual to the behavior of the group, and try to see where there's commonalities and where there's changes, and it's just the way this sort of manifests is again just more like, in my experience, it's just sort of a different layer of data we're using. We're kind of using the application layer stuff to really give us a sense of like, if you're studying like Windows servers do MS update. So if you see an IP address that does MS update and has like a low out degree, like a low number of unique destinations, oftentimes those are like a certain kind of server profile. Whereas if you just look at IP addresses that have like much more non-uniform behavior over time in terms of the number of unique addresses they talk to changes, or maybe there's some the things I like to look for. I don't remember if I put it in here. Oh yeah, like basically there's like a bunch of like little indicators that are like, unless it's like an admin on a server like doing Facebook chat or something, you'll kind of be able to see these two different profiles of people, sort of two profiles of asset classes. One's like a human and one's just like machine driven. And yeah, so this is actually kind of like, typically this is sort of a profile like something in sort of the Windows server land. If I just see this distribution plus a couple other things, I'm like, oh, okay. So this, intuitively, kind of this is sort of what we're overlaying a bunch of these statistics, and we're kind of basically just creating some rules right now to say when these things are fingerprinted as a Windows server or Unix server. And there is machine learning in the background. I don't think it's really that interesting. Like, I mean, it's sort of getting into the weeds, but we do have sort of a workflow that's kind of computing all these statistics. Like, you know, if you want to ask me afterward, please feel free. But it's like, oh, I hope I didn't like get too into the math there. And then one last trick is it's just, I mean, this wasn't really obvious to me until recently, like how valuable. I mean, we're seeing people with just net flows alone doing like a lot of interesting analysis. You know, basically, if you study it's the ratio of bytes sent to bytes received per like session. You can build profiles of client server relationships that way. And like what we're doing for exfiltration is, do I have one of the examples? I mean, basically, like what we're seeing when something gets popped with the web shell, or when a server changes its profile, like the client server relationship changes in terms of the bytes. Like there's really pronounced behavior if you can log the data at scale and kind of ask these questions in like a day-to-day sort of operationalized workflow. Yeah, so I mean, these are kind of like so basically the goal was to just build a bunch of these statistics to give us the ability to say when an IP or like an entity is something like a desktop, where we sort of have a fixed set of different things. you know. But the key thing is, this is sort of the anomaly logic we kind of are working towards, and it's abbreviated in a funny way. But when we say you, we kind of just mean like something that was fingerprinted as a user, or like an end device, just a laptop or something. And then S is sort of more like a server asset. But the important thing what we're trying to look for is some of these relationships that are like, for instance, when we kind of build this profile up and we see like pass the hash or pass the ticket, oftentimes it manifests in sort of this strange like a desktop that talked to a laptop that's never even those subnets never talked before, or when we see like a web shell, like this is like the really interesting thing. So this is sort of what we're after here. Is if we can just profile the DMZ assets, the things in the perimeter that get penetrated, like once we kind of know what we're looking at, then it's super easy to catch when like they've created a new connection to something that they really aren't supposed to. And that's kind of the main goal is oh yeah, it's this beyond the indicator thing. So this is there's a Mannion talk or a CrowdStrike talk called Beyond the Indicator, and I think if you kind of spend some time seeing some of these higher profile attacks and how they're manifesting, like we're really after kind of in an automated way, like just finding some of these edges that are created that are new in the data, and yeah, so that's essentially like the workflow is just sort of walking you through all these steps, and basically the output is this thing. I mean, it's hard to visualize. Like I could have showed you more code, but I did all this with something called Gephi, so it's not like I had to kind of do this offline. But basically, this is sort of like the output of our different steps in a particular environment where I think there's like 25,000 users here. It's a pretty big one. So yeah, so I mean that's essentially the workflow we're using.
Yeah. Right. So.
You're not really starting like with the IPs, basically trying to determine what's normal within some boundary.
Yeah, and building. I mean, also having like kind of predefined notions. Working with someone like Rod or like an actual expert who can kind of come back and the goal is really more like to think about in an environment like what do my servers talk like? Like, do most of my servers, because this can change per environment. So when we build a product, we have to do a lot of like extra stuff to sort of like handle like corner cases. But like when I was doing this like more as a consultant, where I just take like an arbitrary data set and we would just start like, I mean, if Palo Altos are sort of the best. It's kind of like cheating. If you have Palo Altos and we had it from data center to data center, so we would see sort of the east-west data center traffic, which is pretty important. Like, kind of comes back to the difference between routing and switching. Like if most of your flows are most of the data you're looking at is more on the perimeter and routed, then you might have to leverage PCAPs or something else to sort of come up with this profile. But basically, this is like we say like, oh, when we see this, maybe a couple other rules, this is most likely a Windows server in this particular environment, and that's kind of like how I would approach it is like working with him to validate that we're kind of taking the right. Like making sure the IT maps to like the algorithm.
Right, so that's why the asset discovery and type of asset is so critical. Right?
Yeah, and it could get like super unbounded. So that's why we try to when I work on a big like biomedical or places with biomed devices, then we can start talking about like all these different asset classes, or we're talking about HVAC controllers and a bunch of these things that it was getting really granular, So. But I mean, I think the art, like to start, if you just get a fingerprint that tells you when something's behaving like a machine versus a human, like we basically use that as input into more than one analytic, and that I think that's pretty achievable. Like, given, I mean, we do it with just proxy data sometimes because you look at like Facebook stuff and like kind of cheat with social media. I mean, it's not like 100%, but it's one of these data-driven ways to get more signal.
All right, so in conclusion, let's go here. Obviously, this type of approach, we're using machine learning techniques, as you've seen previously, trying to learn to pretty much put together the the techniques and procedures of data science, machine learning, with the knowledge and experience of InfoSec professionals, which at times may present a challenge, because obviously the labeling of the data sometimes can be very challenging. So it's hard, and I can tell you this as the first person, as a researcher, sometimes to communicate with the data scientists it's almost like speaking a different language, right? So, most of us know Metasploit, and here's how I pass the hash, and here's how I create a multi-handler, and here's a client-based exploit, but they see data, they see bytes. So I have to say, okay, wait a minute. When you see this type of bytes, that means there is metabrother there, right? And sometimes you can depend on signatures. We have amazing products such as PAN, for example, Palo Alto Networks, which they're very good at fingerprinting the applications. And sometimes we can depend on static signatures. And here's what this type of approaches help. Because most of the, in my opinion, flawed focus in the industry so far has been to be based in static-based signatures, such as the AB. And we all know what happens with AB. As soon as you obfuscate, repack it, or encrypt the payload, it won't be discovered. So obviously, there's still challenges to tackle, but this is definitely a valid way and procedure to move forward. We're also obviously establishing behavioral patterns that are based on data-driven, and we're trying to provide tools for detecting and predicting unusual, high-risk, and malicious behavior patterns. Obviously, not only in users or in assets, just like he said. Can we tell when it's a server-to-server? Can we tell when it's east-west? Can we tell when it's north-south? Can we tell, well, why is this laptop talking to this workstation? Right? Why is this phone talking to this workstation? Why is this phone talking to this server? So those type of challenges we can definitely. There's obviously there's a lot of infrastructure and new technologies, big data, Hadoop, and we're using Spark specifically in this case that helps in terms of processing and in terms of more efficiently getting our answers, as long as we provide the right data, the right labeling, and obviously you had to train the models. And we actually have been successful catching web shells and new kinds of memory malware using this rare path approach. And I can tell you this without getting in the specifics. There's been places where we have been able to catch customized, crafted exploits that no older device would have been able to catch because they were customized. And we caught it because we apply a multi-contextual approach and a behavior pattern that we have trained the model. So the model will tell you, oh, this looks like this might be this because I've seen it before, right? So this definitely is a battlefield enhancement, like we would say that, right? Yes, sir.
Yeah, I just had a quick question. A couple slides back, you showed Gappy, and
Yeah.
I guess what you guys are doing was showing, I guess you dumped the artifacts from all of those, and you were showing workstation communication. I suppose you could do that with RGP also. Is there anything else that you guys would typically, any data you would ingest that you would want to look at visually from this perspective to try and identify workstation communication or anything else like that?
As far from the data sources, you mean?
Yeah, but like, so what other artifacts would you dump into?
Well, you can. Okay, that's a good question. It's a lengthy process, right? Because have you ever heard of an ETL? Extract, transform, load. It's a big data term.
Yeah.
Extract, transform, load, right? So you had to have ETL experts that basically can make sense of whatever data you're sending. And then from there, then the data goes to the data scientists, right? And then the data scientist said, okay, let's talk with security. And then security does threat modeling. Said, okay, if we see the sequences of events, if we can replicate this type of exploit with all this data, then we can train the algorithm, right? We can tell the algorithm when you see so and so, it's likely that something's going on. Or we can create simple rules, or depending on what models you're using, you will use a different approach. But the sources, as long as they're meaningful, and there are ways to process it, the answer is yes. Any valuable, relevant source can be used.
And well, I think also kind of like some of the more like non-standard. Like this is typically kind of like the let's see here. Yeah, like I think we'd always find kind of stable, like and I mean this is more having visibility into sort of the routed traffic, you know. So this isn't really host-to-host interaction, but there are certain times we were using EPO, like just sort of like more host-based logs. Like in one case, but you know, now I'm thinking about it, I think even when we were using EPO, it was more just to like help. Like it was another data set to do identity resolution because EPO had like the LDAP names for the you know, or any kind of antivirus or even the next gen Tanium stuff. We kind of more would leverage in this. I'm trying to think about like because your question was about visualizing like.
And so you guys would look at the outliers, right? Like
Yeah, well, yeah, it's more like that's kind of trying to illustrate also the sort of the algorithm, like the actual algorithm's evolution on like it's like a job that runs, right? And so we just don't have output in a UI. That's why I use Gephi. But
I like Gephi too. I was just curious what other kind of artifacts you guys would use.
Yeah, so for this one, this is only like Palo Alto and proxy logs, and typically like yeah. So I mean, I'm trying to think. It's a good question. I mean, for the most part, like maybe the only other thing I've kind of leveraged is sort of like more endpoint related. Like you know, like or in smart shops now, if they're starting to do like log forwarding and leverage some of these sort of like techniques that give us more visibility. Because at the end of the day, the issue is we don't have visibility into the host. You know, like my gauge of sort of maturity for a shop when we kind of like we just start a new kind of security conversation is if you give me an outbound IP like a communication, can we map that back to a process on an endpoint? If we can do that, like that's pretty good visibility, but it's usually hard to do at scale. Hope that answered your question.
Yeah, no, it did.
Any other questions? All right, then thank you very
So
much.
you see a lot more SQL stuff going on with this kind of in the future, you know, where you're using ETLs to kind of suck everything in and, you know, go to the, going to the different providers and really finding out who these people are from this IP address and, getting your data validation.
Oh, especially, well, I mean, that's also part of like having kind of a mature sort of intel, like and being able to get external telemetry on anything. If you're talking about like kind of your external address space, that's
Well, I mean, as you build it, you kind of got now this repository that you can kind of say, okay, I see this guy's IP address, I see it's coming from here.
yeah, and so that's why I guess we didn't even talk about passive DNS here, but I mean, there's a couple like key things like if you're willing to kind of go through that pain and like particularly for like external telemetry, if you're leveraging like a passive DNS solution, that's like kind of a holy grail in some cases, more for like the outbound communication problems. But there's a few corner cases we run into. Also for shops that don't terminate SSL, we lose visibility into like I mean that's not really like the asset discovery process, but it's just like getting that visibility at scale. I used to work on a team that was called Greenplum. It was basically data scientists that were starting this like part of the professional services side of this MPP like SQL database. And I think I've seen I think we're seeing more Spark and Hadoop and these MapReduce type jobs in like enterprise applications where it's just more like we're building a product. But like it's kind of like you get a lot for free now if you just stand up this kind of like Spark SQL, for instance. So there's sort of like a lot of ways to attack the problem. It just kind of depends if you're architecting it yourself in house. I would try to like just keep the complexity of the tools low.
Seems like you want to include like your scanners, like
Oh yeah.
exposure.
Oh, yeah.
Qualys and stuff.
Yeah,
To
we
build
do.
your asset identification,
Right.
so that your confidence gets greater and greater over time.
Yeah.
Avoid
Man, I forgot about that. I forgot to add scanners are like a fundamental data source. It's a really good point. Yeah.
Things they can do to log in the machine to tell exactly what it is.
And you used to use the EPO logs plus the scanner information. We call it like population at risk. Because it's kind of funny. It's the AV industry uses this metric too. Is like which users are most likely to get reinfected. Because it's like a measure of a user's hygiene, like browsing hygiene. And so I mean the scanner information is more on the server side of stuff, but like a couple of those data points are sort of fun use cases for a little bit different of a model.
It seems like you build confidence in what the assets really were, and you can profile them more.
Yeah.
boundaries of that type of traffic for that type of asset.
That's like fundamental. I should have included that in this sort of like slide here. So thanks for. That's a good.
Any other questions? Then thank you very much.